All right, first one. Here we go. Interpret change in exponential models. We're going to step away from the algebraic way of thinking about exponents. Okay, we're going to think about more of an equation that has exponents. Are you ready for this? It's going to be super awesome. Are you excited? Okay, sweet. After the last ice age began, blah, 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 blah. Okay, here we go. Every year, the number of, let's just complete the following sentence about the yearly percentage change of number of animal species. Every year, blank percent of species are added to, subtracted from the total number of animal species. All right, so here's what we need to know. This percentage, this growth rate, is always present right here. This thing in parentheses right here. This is the growth. All right, it is represented usually as a decimal, sometimes a fraction, something like that, maybe a percent, right? So the question here is, what does this mean? Well, what's happening is we're starting off with a population of 4.2 million. That's what that means. And then every year after that, this 4,200,000 is being multiplied by 72%. So if I take this times 0.72 every year, what's happening to the population? It's getting smaller, right? How do you know it's getting smaller? Bingo, right? It's under 100%. It's under the decimal form 1, right? It's under 1. So anything under 1 means the population is reducing, right? It's subtracting. So this question here down the bottom is saying every year what percent of species are either added to or subtracted from. First of all, we would say on this one, subtracted from. What percent is subtracted? Right. Good. 28. 72 is left over, right? So if we did 1 minus 0.72, we get 0.28. That's what we want here. So 0.28 is the decimal form. Do I write 0.28 though? I write 28. Okay. How about this one? This is worded a little differently. It doesn't say added to or subtracted. It says grows or shrinks. Does this one grow? It grows because this growth factor in here, okay, it grows. Oh, man, I wish that would let me do that. All right, so grows by a factor of 1.53. All right, so now if this was the other question and it said adds or subtracts, what would we say? We would say adds what percent? 53%. Adds 53%. When they use this language, by a factor of, and this is key for the whole unit that we're about to begin. When it uses the words by a factor of, it just wants that number that's in the parentheses. Okay? 1.53. Easy enough, right? Okay, now here's another one. Now we're going to talk about time in exponential models. So that first one was interpret, the growth rate, right? We're going to try to do a few of these today. Complete the following sentence about the rate of change in the locust population. The population of locusts gains 2/3 of its size every how many days? Tricky. If we notice this growth rate in here, it's 5/3. Now, keeping in mind that 5/3 is really like 1 whole plus 2/3, right? It's really like 1 and 2/3, right? It's the same thing, same idea. So this amount that it's adding is 2/3, right? It's adding 2/3 every time. How often do you think it's happening? Just any guesses? Look at the equation. One clue is you can just look at it and answer it. 5.9 is correct. I heard it 3 different ways there. Very good. So this is the amount of time for it to do that, right? So this number that we're dividing by, that's our time right there. That's how many days it takes or how many years or whatever, the amount of time that it takes for this growth to happen. On all the examples that we just did a second ago, it just said T up there, right? Okay, so that would happen every 1 year or every 1 day or whatever the time unit is. Okay, so here's another one. Complete the following sentence about the rate of change in the number of branches. Every how many years the number of branches increases by an additional 64%? 3.4, yeah. And we would say that because this means adds 64%, right? That's exactly what that means. How often does it happen? Every 3.4. Okay, last one. The number of tigers is reduced by a factor of 1/3. Remember the language of by a factor of this phrase? That's what this means. Happens how often? Every 2 years. Very good. Now let me ask you this. What if the exponent, let's just say it was something like this. What if the exponent was like this? How often does it get reduced? Instead of divide by, what if it was times? What would that mean? This means every 2 years. This would not mean 5 years. 5 years would be T over 5, right? What would this mean? Any guesses? 5 times a year. So that means it happens.
1/5.
Awesome. 1/5, every 1/5 of a year. That's what that would mean. So you're going to see that maybe not in this assignment, but later on. Okay. Questions on these two to begin with? All right. This last one is we're going to actually build the equation. So they're going to give us the info and then we're going to type in the equation. So here's the important parts. You can just, if you're writing this example down, just write down these parts. Loses 25%. So I'd write that down. Loses 25%. Every 14 seconds. I'd write that down. Then also you should say the start or the initial amount. Most people use the initial amount is 45,000. So I kind of hinted at this earlier, but 45,000 is what we should type first. Then what? Why 0.75? Awesome. Very good. So 100%, and we're losing 25%. That tells me 75%. So 0.75 in parentheses. And then the last piece is the time, right? How often does it happen? T over 14. Now, what you'd really want to watch for is make sure the units match up, right? So, for example, this one's in seconds, and it was in seconds. But it could be a scenario where it happens every minute, and they ask you to write it in hours or something funky like that, right? So this is what we're going to write. We're going to write the whole thing like this. It gets a little weird. You don't have to write 0.75, but I do. I would hit the exponent button, and then I would hit the fraction button. You got to hit it in that order. Okay. You want to try those? All right, very good.
I feel like it's going to be